Ladies and gentlemen, welcome to my presentation about our research project concerning the acoustic behavior of CLT with phasing layers. Starting point of our considerations was the simple fact that sound insulation of a simple CLT slab is too low for most of the application in buildings. This is shown as well here in this graph for different thicknesses of the slab, as well as for the single number values of the sound reduction index. So the sound insulation of CLT is improved by phasing layers. They consist of a second mass connected to the CLT with a spring. The spring usually consists of hangers. We tested two types of hangers, one hanger with and one hanger without elastic interlayer. In order to get a better understanding of the vibrational behavior of CLT with phasing layers, we created three different test settings: small, medium and large test setting. The small test setting consists of concrete pavement slabs, and we varied the amount of these pavement slabs in order to simulate the CLT with different plasterboards, but also different distances of the hangers. The medium test setting we created had the size of a standard plasterboard. There we measured phasing layers with different distances between the two boards, with different plasterboards, with 1 and 2 layers of plasterboards, and with and without gap filling with insulation material. The large test setting was a standardized transmission suite with a CLT wall with the dimensions of 4 times 2.7 meters. There we also varied different distances and amounts of plasterboards and types of plasterboards and different hangers as well. And we carried out several measurements of sound pressure level in 1/3 octave band, sound pressure time signal with FFT transformation. We measured the structural reverberation time, and we also did acceleration level measurements with airborne and impact excitation. This graph shows an excerpt of the results of the large test setting. You see the sound reduction index over the frequency. The dashed lines are the results for the 1 Hz measurements, and the solid lines are the ones for the 1/3 octave band measurements. The black line is the plain CLT slab, and the colored lines are the results for different phasing layers, where hangers are varied and distances between the slabs as well. This graph shows the lower frequency range of the sound reduction index of the red curve from the last slide. It's a phasing layer with 5 centimeter distance to the CLT slab and ordinary hangers. Indicated with M, the 2 eigenmodes of the slab, and FR is the resonance frequency we found in this curve. We already carried out a lot of different measurements. Now we have to analyze and compare the results from the different test settings from S to L. We still have to verify the relation between the resonance frequency and the sound insulation in order to develop a simplified calculation method, and we still have to carry out the performance checks of our self-developed MEM measuring system. Well, thank you for your attention. I hope this was interesting for you, and I'm happy to answer your questions. Thank you.